guys, hope you're having a good day so far. I'm going to talk to you about domain and range today. And domain and range are just function vocabulary that you use the same as you would use X and Y or input and output. Okay, so you can use a table, you can use a set, you can use a graph, you can use mapping diagrams, all of those things to represent, normally they're functions, but we don't know if they're a function yet, so we're just going to call them relations. So a relation is just really a set. So I have this set, and the domain would be everything that's in the first spot. Like remember that it goes X, comma, Y. So the domain would be -5, -4, -2, 0, and 1. And you can put that in order. It is in order, so I would leave it like that. Now, domain is the X, so you can also put it in the X column. You can also put it in the first oval for your mapping diagram. Those would all be like similar places that you would put domain. So domain is the set of X's, the input. And then you have the Y's. So that would be 4, -1, 1, 4. I already wrote, so I'm not going to write it again. I'm going to make that a 3. Okay, and again, you can put that in order. Okay, now I might want to put it in order when I put it in my mapping. But when I put it in my table, they have to stay ordered pairs. So the 4 has to be with the -5. The -4 has to have the -1. The -2 has to have the +1. The 0 has to have the 4. And the 1 has to have the 3. But since I chose to put it in order, my arrows might cross. So I just draw an arrow from -5 to 4, from -4 to -1, from -2 to 1, from 0 to 4, and that's okay. You're allowed to get 2 arrows, and from 1 to 3. All right, so things that are okay. Like it is okay that arrows cross. That's not a big deal. You just want to try to be as neat as possible. And it is okay that a number receives 2 arrows. What's not okay and makes something not a function would be if something was to give 2 arrows, because each input can have only 1 output. All right, so just pause the video and try number 2, and then unpause the video to check your work. Okay, so -3, -1, 0, and 2. -3, -1, 0, -3 I already wrote, and 2. And then range, -4, 2, 0, 5, and 4. So again, I'm just copying it, -3, -4, -1, 2, 0, 0. That's the origin. -3, 5, and 2, 4. Okay, so now I'm going to do the same thing here. -3, -1, 0, and 2. -4, 0, 2, 4, and 5. Okay, so -3 has an arrow to -4. -1 has an arrow to 2. 0 has an arrow to 0. 2 has an arrow to 4. And here's the situation that's not good. -3 gets a second arrow to 5. And that makes this not a function. Okay? So the question below says, are both examples above functions? No. If no, which example is not a function? Example 2. And I just really want to say because, and I apologize for my handwriting, -3 has 2 outputs. And you can phrase that in a few ways. You can even refer back to the mapping diagram. Okay, so when you have an input of -3 and you have an output of -4, you're fine. But then when the -3 repeats with a different answer, that causes a problem. It's still a relation, but it's not a function. Okay, for graphs, we need to work a little bit harder. Most graphs are continuous, so we will need to use inequalities or interval notation. All right, so continuous just means that it's all connected. So think of the word continuous as continuing or connected. Okay, so the above relations, these are discrete because those would be like a set of points. They wouldn't be connected. All right, most graphs are continuous. Not all graphs, but most graphs. For domain, scan your pencil. So now remember, domain is the value of x's, and x's go from left to right. Okay, for range, remember that's the value for y's. And I know this sounds strange, but I'm going to say from down and up. I really want you to go from down to up because in mathematics, it just makes more sense for people to start with smaller numbers. So if you think about or you look at a y-axis, the negative numbers are on the bottom. So we want to go from down to up. All right. All right. So here's a picture. For each of the following, first identify if the relation is a function. Okay. So for this first one, yes, that is a function. It's actually called an absolute value function, and you can tell that when it looks like a V. Not piece, absolute value, okay? So that's an absolute value function. Or it might not even be absolute value because they're not identical on both sides. So actually it's just piecewise because I don't think they have the same slope. Okay, all right, so that's a function. Regardless, it's a function. Okay, if it's a function, name the domain and range. So if I go to the left, I see an arrow. So that's going to be -infinity. And then if I go to the right, there's also an arrow. So that's going to be +infinity. All right. Now, when I start down, there's nothing down here. The lowest point I have is this one here at -2. So that's where it starts at -2. And then it does go up forever. So that would be infinity. We would call that -2 a minimum. All right. So if the relation is a function, then okay. So this is not a function because it doesn't pass the vertical line test. So all you have to do is say no, not a function, doesn't pass the vertical line test. So I'm not going to answer domain and range. Okay. This is a linear function. So that is going to be a yes. And the cool thing about linear functions, when they have the arrows on both ends, that means that it goes on forever. So it's going to be -infinity to infinity and -infinity to infinity. That's pretty cool. Okay, so this is a function. It passes the vertical line test. You can just draw your vertical lines or pretend to draw them. So I'm going to say yes here. And then I'm going to go to the left, and I have an arrow. So that's going to be -infinity. And then I'm going to go to the right. That also has an arrow. So that's going to be infinity. And then I'm going to start down low. And it does, like on the bottom where it starts, it has double arrows. So that means like it goes down forever. So that's going to be a start at -infinity. But then when I go up, it stops. 1, 2, 3, 4, 5. It stops right here. So that's going to be 5. And that's a hard stop. So that's going to have that square bracket. So it stops at 5. Let me double check my counting. 1, 2, 3, 4, 5. Yeah, so that stops at 5. That is definitely a parabola. I know I called the first one absolute value by mistake because I didn't check my slope, but that is definitely a parabola. Okay, so pause, stop the video, try to do some by yourself, and then turn it back on. Okay, some really cool ones. Look at this. Okay, so this would be a no. because it doesn't pass the vertical line test. And this is actually a yes. It's kind of cool. All right, so if I go to the left, it's negative infinity, and if I go to the right, it's infinity. But it looks like this is the lowest. 1, 2, negative 3. And it looks like the highest is at 2. So if you look at the y-axis, it looks like it's kind of squeezed in between this negative 3 and this positive 2. Okay, so that's a horizontal line. Horizontal lines are functions. And it has arrows on the left and arrows on the right. So that's the double infinities, or negative infinity to positive infinity. Okay, now the range is kind of boring. 1, 2, 3, 4, negative 4. 1, 2, 3, negative 4. So the range is just negative 4. Like, it's just a point. So, I mean, I guess we could just say y equals negative 4. I mean, I'm not sure if the interval, I don't know. I mean, let's write this, and I can always double check that for you. Okay, so this is a function. And if I go to the left, it looks like negative 2. And if I go to the right, 1, 2, 3, 4, 5. So it's going to be a hard stop at that negative 2 and an open circle at the 5, because you can see it's got that open circle. Okay, this is also the lowest point right here, and that's a negative 2 for the y direction, 2 below. And it looks like this is the highest, which would be 1. So we're going to have a soft negative 2 and a hard stop at 1. Okay, not a function. A parabola like sideways is not a parabola. It's a reflection of 1, but you don't have to know that. So we're just going to say no. Okay, this is kind of cool. This is piecewise. Piecewise just means that it's a series of pieces, like put together. So like this is going to have an equation, this other piece is going to have an equation, the third piece is going to have an equation. But it is a function. It's called a piecewise function. All right, so if I go to the left, that's negative 2. And if I go to the right, it's got that arrow up here. So that's going to be infinity. Now if I go low, that's negative 4. And if I go high, it's got the arrow. That is kind of cool. I mean, basically this point right here, it's the furthest left, and it's also the lowest. So it creates the end point for the function. So that's kind of cool. Well, that's domain and range. I know the graphs are a little tricky and you just have to practice it, but I always think of it as, look to the left, look to the right, look low, look high. If you want, you can almost draw a box around it. Let's see if that helps you. Like, see, this is the lowest and this is the leftist. Lowest and the leftist, and then over here you have the arrow. And that's why you have the infinities. Well, hope the video helps, and I hope you have a great weekend, and I'll see you on Monday.